So when we do that, you can see it's parsing it. It's found hex 4E structures, that many unions, that many opcodes.
So just, if you see all this data is, you saw the structure was pretty simple. You had long, you had, arrays and things like that. And, this data shows a lot of that information. But what you're not seeing sometimes is padding. There's necessary padding for each structure or alignment, and different array types, require different data to be packaged with it. So, that's all done for you, and we just printed it out so you can see it.
And you can see we hit the breakpoint. I don't know if you can read it down here, but it says breakpoint hit. At this point, you could begin your audit, and you can set any of the data back in the original script that parses and sends the opcode across. So you could say, I want that long element 4 to equal, hex 20. So then you can sit here and audit and actually see your data. I'm going to go ahead and just let this go, and you'll see it access violation when executing 0. So this is a stupid bug on their part. They jump into a DLL that they haven't loaded yet. So if you had some kind of 4-byte overwrite, you could fake this vtable and get execution. I mean, there's a lot of bugs in this program. Like I said, they have 400 opcodes. It's kind of obscene. But this one will actually crash the service entirely. If I pass that exception, the whole thing goes down and the service dies. So CA doesn't know about that, but I'm sure they probably don't care because they have worse things to worry about. But yeah, this error is just because the service died, so it doesn't know how to respond to that specifically.
Pull up the service ID.
I'm just going to pull up one of the Microsoft IDLs real quick so you can see.
Or RPC it says. Show IDLs are generated from 2K.
Okay.
A lot of the well-known RPC services that are in something like Windows 2000, everybody knows about. But when you actually run our scripts that dump all the DLLs that provide an RPC pipe, you'll see there's actually quite a lot of them. Some you'll know, LSA serve, locator, spooler, but then there's also these other ones that a lot of people haven't seen or looked at because it may be a lesser used service. Some people may not have it started, things like that. So, there's quite a bit that Microsoft even has left that people aren't really looking at. So.
And a lot of these have not been fully audited at all because we found some simple bugs in these that it's not simple quite to reach them, but the bugs themselves are simple. Our toolset makes it a lot easier because you don't have to worry about any of the marshalling issues. But I mean, some of these bugs, they'll be 6 structures deep, and it's a Stack Overflow. But because nobody's been able to actually talk to the service before, you may not see these things. Some of these are quite large. This specific IDL is one of Microsoft's, and it has something like 6 or 7, I guess, interfaces exposed, RPC SS. I'm going to show you something we have in the works, which is our GUI that'll allow you to actually have a visual representation of this stuff. This is
we did this, last week, like the day before we left, so it's a little crude, but this is a WX Python GUI, and we did this so that you can visualize how all these data structures are linked together. In the final version, which we will probably finish next week or maybe the plane run back, you will be able to click on an object, show what the data for that object is in the right pane, and edit it and then send it over the wire. And we have menu hooks to set up a host, set up things like that, so that you can just take an IDL, pop it in this GUI, it automatically splices it together for you in the correct data structures and functions, opcodes. And then from there you can go in and manually touch different pieces of it for code coverage purposes or whatnot. So if you notice, we talked about embedded structures, things like that get pretty complex. If you look at one of these opcodes, argument 3 of that function has 2 longs, an array of strings, and then embeds, or has an array of
W strings.
I can't see that far.
This looks like a wide character string. I mean, these things can get arbitrarily complex. This is not one of the most complex ones, and you can see it's a few structures deep. But like I said, marshaling some of this data can get extremely difficult.
Server service.
This is server service.
Or edit the GUI.
But
We'll show another one that gets pretty complex. And it's really nice to visualize it in the GUI. You know, when we're just dumping hex out, you can't tell all the different items that are being sent across. So it's kind of why we did the GUI. That's still RPC.
the last one was server service. This one is RPCSS. You can see that this one has a bunch of different UUIDs. So
these are all the available interfaces you can talk to. So with the script, you know, you can put, I want to talk to the second interface, call opcode 3, and provide this kind of data.
So I guess that's it for the Microsoft IDLs. If anyone's curious about this CA one, you can essentially call any of the first 20 opcodes and crash the service instantly, which takes about 5 seconds. But I guess that's it for the demo. Let me see. Yeah, I guess, are there any questions?
Have you looked into doing any like on the wire protocol analysis, so like off your IDL shooting for that, or your endpoints, say looking at what's going through Wireshark rather than just having the lump of stub data that's always a bit to actually pass by hand, kind of link that into your marshalling, so it can marshal in, say, Wireshark, and I can see the values which are being passed between two points on the network.
We've actually done the opposite. That makes sense, though. We could easily do that. We mostly were sniffing traffic to see why we were screwing up originally, to get a better idea of how it was marshaled, but we could easily, using our NDR library, unmarshal data on the wire, which would probably be pretty useful for Wireshark, because I know that they're missing a lot of the protocol decoders. Yeah, they handle maybe Spooler and a few others, I think. Yeah, so actually that's something viable we could probably do. So we have a pretty good understanding of, having done all these by hand, how to unmarshal a huge block of stub data. So something to look into. Anybody else? I think that's all we had, essentially. We early? We're a little early.
No more questions at all? Nothing.
Okay. Guess we're going to cut it short then. Thank you.